So, a very good afternoon to all of you. Today, we are dealing with another unit of power station practice, and this unit is basically the generating station. Last time we are covered about substation, in which you are discussed about the substations, the classification of substations, different equipments used in substations, the line or a key diagram of 11 kV by 400 volt substation, and also we will discuss about the line diagram or a key diagram for a 66/11 kV step down substation. So today we are coming with another topic or another unit of power station practice, and this unit is basically related to the generating station. I had already explained to you in my introduction lecture in power station practice that the power station practice can be counted by the three main terms of the power system, that is a generation part, that is a transmission part, and a distribution part. Now we are dealing with the generation part, sorry, we are dealing with the substation part. Now today we will discuss about the generating station, how a power can be generated in a generating station, by which means we can use the energy, and by what form of energy can be converted into another form of energy. Now you can see on your picture you have a different type of power plants. Like, you have, first picture will be hydroelectric power plant, number two will be thermal power plant. And see, I can tell you the picture of this hydroelectric power plant is a real picture, and this picture belongs to Baglihar hydroelectric power plant. ये वाली पिक्चर मैंने खुद क्लिक की हुई है बगलियार हाइड्रोइलेक्ट्रिक पावर स्टेशन की. So it is a Baglihar hydroelectric power station, and here you have a thermal power plant. We will discuss later on by coming lectures what do you mean by this hydro, thermal, and all that. This is, you have another picture in which we are representing the nuclear power plant, and your fourth will be gas power plant. In addition to that thing, there are more generating stations like solar generating station, wind generating stations, ocean thermal energy generations. But for examination point of view, or for your curriculum point of view, as per the University of Jammu has decided your syllabus, in your syllabus there is only the four generating stations, and these four generating stations are your hydroelectric power plant, your thermal power plant, your nuclear power plant, and gas power plant. So we are discussing one by one. What do you mean by this hydro? What will be happen in case of hydro power plant? What will be happen in case of a thermal power plant? What will be happen in case of a nuclear power plant? And what will be happen in case of a gas power plant? Is it audible to all of you?
Yes,
Yes,
sir.
sir.
Okay. Now, before discussing about the different types of power plant, let's we have a small video for you people. You all are requested to please turn off your mic and see the video carefully. So I think with this video you can get an idea about the generating station. Is this audible to all of you?
Yes, sir.
So by this video you can get an idea related to the generating station, and in this video I have to cover almost all the type of generating station that we are available. For example, we have a hydro, we have a thermal, we have a nuclear, we have a biomass, we have a solar, and all that. But as I already explained to you, in your Jammu University syllabus there are only 4 type of generating station that you have to be covered, and these 4 type of generating stations are hydroelectric power station, your thermal power station, your nuclear power station, as well as your gas power station. Is it clear to all of you?
Yes, sir.
Okay, as you seen on your video that there are different type of generating stations. So first of all, you have to be noticed down what do you mean by this generating stations. So a generating stations are also basically called as the power station, and a power station referred to as a power plant, and sometimes it is called as the generating station or a generating plant. It is basically one type of industrial facility for the generation of electricity, and these power stations are generally connected to the electrical grid. That means you can say that in case of a generating station or a power plant, what we have to do, we have to convert one form of energy into another form of energy. The input energy is converted into the electrical energy, and the type of input energy available are defined as the different type of generating stations. For example, if you have the input energy is hydro energy, then this hydro energy is converted into the electrical energy, then the power plant is called as hydroelectric power plant. Whereas if you convert the fuel energy into the electrical energy, and the fuel is something like coal or a petroleum, then this type of power plant is called as the thermal power plant. And if you use the input fuel as a nuclear fuel, then that type of plant is called as nuclear power plant. And lastly, instead of coal or a nuclear, you can use a gas or some petroleum product for the generation of electricity. So that power plant is basically called as the gas power plant. So as I have already told you, in your syllabus you have the 4 type of generating stations. So we will discuss one by one what are these type of generating station, where these type of generating station be installed, what are the advantages and the disadvantages of all these type of generating station, and after that. Now, another introduction about this generating station is many of the power stations contain more than one generator, and this generator are basically the rotating machine that converts the mechanical energy into three-phase electrical power. And after that, this three-phase electrical power is transmitted with the help of a transmission network by using a transmission lines, the power transformers. And after that, this power can be distributed with the help of a grid station, and this whole network is basically called as your power system. It is clear? It is
Yes,
clear?
sir.
Okay.
Yeah.
Continuation to the part of introduction about the generating station. The energy sources harnessed to turn the generator varies widely. Most power stations in the world burn fossil fuel such as coal, oil, and natural gas to generate electricity. Clean energy sources include nuclear power and an increasing use of renewables such as solar, wind, wave, geothermal, and hydroelectric. So this is all about the introduction part of your generating station, how this generating station will work, and in what type of generating station, what is the input energy and what is the output energy. But only thing that you have to be remembered, in all these generating stations or a power plant, your output will be electrical energy, but your input energy will be varies accordingly the supply. For example, we have a hydro, we have a coal, we have a nuclear, and we have a oil or a gas. Now we will start your first point or a first generating station, that is called as hydroelectric power plant. आप में से कई लोग अभी अपनी इंडस्ट्रियल ट्रेनिंग किसी ना किसी हाइड्रोइलेक्ट्रिक पावर स्टेशन से कर रहे होंगे, isn't it? Anybody जो अपनी इंडस्ट्रियल ट्रेनिंग किसी हाइड्रोइलेक्ट्रिक पावर स्टेशन से कर रहा है, कोई बता सकता है? अभी लोग, आप लोगों ने जो अपनी इंडस्ट्रियल ट्रेनिंग करी है या कर रहे हैं, किसी न किसी ने अपनी इंडस्ट्रियल ट्रेनिंग जो है वो अपनी हाइड्रोइलेक्ट्रिक पावर स्टेशन से करी है, किसी ने? if I say on a hydroelectric power station or a simple language, what will be happen in case of an hydroelectric power station? The water is stored at a certain height, and when the water is stored at a certain height by creating a dam, then the potential energy of the water is increases. Now, after that, what will be happen? This water that is stored at a high end, it has a high potential energy. It will be starting flowing from high potential to low potential, so that potential energy will decrease, and at the same time, your kinetic energy will start increasing. The high pressure water is then strike to the turbine. There is a water turbine, and the turbine can start rotating. And when this turbine gets start rotating, it is coupled with the alternator. And when the alternator start rotating, it produce electricity. Because according to the principle of alternator, whenever there is a change in the magnetic flux, and EMF is generated. So this is the whole principle behind hydroelectric power station. So you can see on your diagram, that is a hydroelectric turbine converts the energy of the flowing water into mechanical energy. Hydroelectric generator converts the mechanical energy into electricity. The hydropower does not pollute the water or the air. However, hydropower facilities can have a large environmental impacts by changing the environmental and affecting land use, homes, natural habits in dam areas. So hydroelectricity is electricity produced by hydropower, and it can be estimated that in 2015, the hydropower generated is 16.6% of world's total electricity and 70% of all the renewable electricity, and was expected to increase by about 3.1% each year for the next 25 years. That means this data is according to 2015, that the hydropower energy generation takes about 16.6 world total electricity production, and 70% of the renewable electricity was expected to increase by about 3.1% each year for the next 25 years. Hydro energy or hydropower is produced in 115 countries, with the Asia Pacific region generating 33% of global hydropower in 2013. And the China is the largest hydroelectricity producer with 920 tegawatts of electricity production in 2013, and representing 16.9 of domestic electricity use. So again, you can say that China is the first country that is the largest hydroelectricity production. The cost of hydroelectricity is relatively low, making a competitive source of renewable energy. The hydro station consumes no water, unlike coal or gas plants. So you can say that the hydroelectric power station, it has no doubt initial cost is high, but their running cost is almost equal to zero, because there is nothing can be consumed. The water will enter to the turbine, and after rotating the turbine, it will go outside. So nothing can be consumed in case of hydroelectric power station. So you can say that using of electricity, generating of electricity by the means of hydroelectric power station is something economical. The technical potential for the hydropower developed around the world is much greater than the actual production. The percent of the potential hydropower capacity that has not been developed is 71% in Europe, 75% in North America, 79% in South America, and 95% in Africa. So this is the data that I have taken from the reference of the Google. So how the hydroelectricity power will be generated, and what are the various countries that can contribute in hydroelectric power generation. Now, coming to the part that is the generating method, it is audible to all of you. If anybody having any doubt, he or she can ask me. Yeah, anybody having any doubt, he or she can ask me. Can I continue?
Yes,
Yes,
sir.
sir.
Okay. So the generating station. Generating station means I will discuss here about only the hydroelectric power station. Now you can see on the top there is a diagram, and this diagram is basically the line diagram for any of the hydroelectric power station. You can see you have a upper part is the generator, and the generator having the two parts, that is the stator as well as the rotor. Now this generator is connected with the turbine, and this is the turbine shaft. And here these are the blades of the turbine. The water is striking at these blades. This will rotate, and when this will rotate, the turbine is also rotate, and this turbine is rotate. The generator is also rotate. Now, when the generator is rotate, according to the Faraday law of electromagnetic induction principle, an EMF is generated. Now, any of the hydroelectric power station can be classified into three main categories, and that three main categories is ultimately dependent upon the type of scheme they can use. So accordingly, we have number one, that is called as conventional dam. Number two is called as pumped storage, and number three is called as a runoff river scheme. Now, all the three dams, these are all, you can say that the dams, and these dams are constructed on a river depending upon the supply of the river. For example, if you have to pump the water from lower level to the higher level, and after that you can uh, injected the water from high level to low level, we are using a pump storage. If you have a runoff river scheme, the normal water is flowing in a river having a high potential. In that case, we are using a runoff over river scheme. And if you have not a pump storage as well as a runover river scheme, in that case, you have to create an artificial barrage in the river. And this artificial barrage that you have constructed in the river is called as your dam, and after that you can strike the water from high level to the low level. Clear? So after that, I have one video with you people related to the hydroelectric power plant. You can get an idea how this electricity can be generated in case of an hydroelectric power stations. So here is the video of hydroelectric power station. You all will see this video patiently, and after that we will discuss about this hydroelectric power station.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity: large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources, as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
So I think you all get an idea about the hydroelectric power station. It is a videos you understand. It is beneficial to you to understand about the thermal hydroelectric power station.
Yes, sir.
Yes, sir.
So this video represent about the, you can say that the hydroelectric power station, the hydroelectric power station, how the hydroelectric power station can work. You can see the water is start rotating the turbine, and when this turbine is coupled with an hydro generator, and this hydro generator will start rotating, and according to the Faraday law of electromagnetic induction principle, and here we have the electricity will be generated, and after this electricity will be transmitted through with the help of a power transformers and the transmission lines. Now another important thing, that the choice of site of hydroelectric power plant. When you have to install the hydroelectric power plant, firstly you have to allocate its site location. And talking to the site location, these are the four important things that you should kept in mind while selecting the site for any of the hydroelectric power plant. And this is number one, that is availability of the water. Then number two will be the storage of the water. Number three will be cost and the type of the land. And number fourth will be transportation facilities. So any of the hydroelectric power plant which we have to be installed, whenever this hydroelectric power plant will be installed, so before installation of the hydroelectric power plant, these are the four site specifications that should be kept in mind for you can say that select for installing a hydroelectric power plant in any of the area. For example, if you talk about Jammu and Kashmir, you have a Baglihar hydroelectric power station that is situated near, you can say that Ramban in Chandarkot. After that, we have a Salal hydroelectric power station that is in Riyasi. Then we have another that is called as Punjab Chamera hydroelectric power station. So all these hydroelectric power station, they have, when they are installed, when they are located, when they are built, all these four categories, that is the availability of the water, your storage of the water, your cost and the type of the land, and your transportation facilities can kept in mind when you have to select this hydroelectric power plant. Clear? So this is all about on today lecture. On tomorrow, I will discuss with you people that what do you mean by this hydroelectric power station in a detailed way. What are the various equipments that we can use in our hydroelectric power station? कौन कौन से इक्विपमेंट यूज किए जाते हैं हाइड्रोइलेक्ट्रिक पावर स्टेशन पे, जिसकी वजह से हम लोग अपनी हाइड्रोइलेक्ट्रिसिटी पावर को जनरेट कर सकते हैं. And after that, we are discussing about advantages and the disadvantages of this hydroelectric power plant. So anybody having any doubt, he or she can ask me for today's lecture. Anybody having any doubt? Okay, after this lecture, I can record this lecture and put it on YouTube also. I can provide you the link of the YouTube. You can watch this video again and again so that you can get a better understanding about this hydroelectric power station. And also I will share with you the writing material or the study material related to the hydroelectric power station. So with this, I conclude my today's lecture, and tomorrow at our scheduled time, I will meet and continuation this hydroelectric power station. So as